clearly I provided some of the sort of like the start for you folks. We've got the merge function up here. We have exec, count, and limit. And now we're going to start with where. Okay. Let me see. Oops. Where's rid of this? Okay. Anyone tell me what this where is doing? What it needs to do? Anyone just want to like tell me what to write? Make my job really easy. No. What does where need to do? Yes.
Where should take some filter objects,
Mm-hmm.
and what you want to do is you want to return every row in your table that matches the filter.
Okay. It takes an object, right?
So what you're going to do is you're going to filter out everything in your current data set that matches where the columns for the keys on the values on the object.
Great. Yes, and I think one way of saying that is find every row that matches all the criteria in the passed-in object, right? My font bigger. Yeah. If I can, good? Great. Okay, cool. Yeah, please let me know if you can't see. Okay, great. So this is what we're going to do. All right, so I'm going to start doing that. You guys can tell me if you want me to do it a certain way. Anyone use object.keys? Kind of handy. Great. Awesome. So we got these keys, and we need to return an array of filtered objects, of objects that match all of the criteria, right? So we can do this, results, and this is going to, wait, and I need to filter on this data, filter function, row. Okay, now what? So I have to now check every key by the row. Rows, or at least that's the table that I used. Did anyone use every for this? Kind of like a useful array prototype method. Every. And so this would be every key. Are you trying to, what's that? Okay, cool. Want to make sure. So, and then there's this additional check of checking whether it's a function, right? So it is a function. So type of, what is it? Type of key is function. Is that right? Or rather, not the key, but the object of that key. That is a function. Then do what? Anyone? Anyone? Okay, yes.
Then you want to see if the value from your row returns true in the function.
Okay, and how do I know whether if that function will return a Boolean?
Because that's how it works.
Yeah, it's just a function. If this function is going to be passed in, it has to return a Boolean just like filter, right? So I can then just invoke this function with my passed in, with my object, the key of that object, and just return that value, right? Because this is what you, if anything I'm doing just seems off base. Okay, and then return object row key. Right, so if it's not a function, if it's just a property, if this is a prop, if it is a function, do this for every row and every key in the pass-in object. Okay, so we're iterating inside of an iterator, which means that we're stopping on each row and then checking each key by that row. It's like a nested for loop. Anyone want to tell me what the time complexity of this is? I think you guys learned about this with Gabe, right? Yep, that's correct. Nested for loops are what a polynomial exponential, right? So like two nested for loops, that's n squared, 3 and cubed, on and on, right? And what we have in every, right? So filter's a for loop, every is a for loop, they're nested. Cool. Does this look good? Okay.
So methods like filter and every are not better because they're faster, and they're usually better just because they are more abstracted from doing like a for var I equals 0, like that, those types of for loops.
Yeah, it depends on what you mean by better. Actually, if I were to write a for loop, that's even faster than a for each. For each is not faster than a for loop. But I like to use every and filter because it's clear what they're doing. It is an extra level of abstraction that makes it more expressive. So it's like every, it's like exactly what I want. Does this row have the criteria by every key in this object that's been passed in? It has to pass all of the criteria. So I think it's just very, yeah, semantically apt. Cool. Okay, so let's see if I pass anything. No promises. My PM test. Oh, I've got missing a comma somewhere. Let's see. This should function only be clear at top level. I immediately get another function. Oh, that's interesting. I'm missing just. Anyone going to tell me this? Okay, so I've got all these pendings and I got some trues. Great. That's exactly what I want. I think I should be passing about 4 or 5 right now, and I am. It's a good thing. Okay, so let's see. What have I taken off? Okay. Oh, should have a limit method. That's the, yep, got limit. Hit the limit. Exec. Here we are. We got where. Let's take this off. This. Cool. How else did you guys do this? For loops. Cool. Let's do that again. Okay. So, cannot call exec of undefined. Okay. Let me keep this up here. Okay. So I've got this cannot call exec of undefined. Let's see what that's about. 102. Oh, you're totally right. I should be doing this, right? Is that what you're talking about?
We plug results into a new table.
Ah, yes. So did you guys try, so let me guess, you did turn new FQL, right, for chaining, right? Okay, cool. What's that? Where am I? Yeah, I'm terrible with this. Don't just say what I do, you know. Let's see, or do what I say. That one. Okay, great. We're passing. Yeah, does that make sense why I'm plugging this into a new table? I can make this bigger for you guys too. Yeah. Okay, great. Yeah.
understand what, like, if it is a function, you're passing the value of that row in, like line 58 and 59.
Yeah.
Particularly 59.
Yeah.
I just don't understand, like, so you're passing into the function the value of that key, that row at like,
Okay. Well, is each object, right? So this data, this data is an array of objects, and I've got this object. I should call this query object. The passed-in object is full of criteria, right, that I have to match against, and I'm going to return an array of row objects that meet all of the criteria that's passed in. And so in order to assess that, I have to go through each key in this row object and see if it evaluates to true when matched with the row that I have. And so for each key, I have to access the property of this object. That's what I'm doing right here. And if it's a function, and I pass in the key of that row, so rows, yeah. If I pass in the data of row at that key to the function that's defined, it returns true. There we go. Okay, great. Okay, great. So we're set with where. You guys seem comfortable. Great. Select. Select is next, right? Okay, and what does select have to do? Anyone? Anyone? I'm guessing it has to select something, right? I mean, I don't know. I did this a while ago. Help me out.
Select the right keys that you pass in.
Select the right keys that I passed in.
Yeah.
And return only the objects with those keys. Okay, great. Right, I remember this now. Okay, great. I'm just gonna breeze through this. We're all tired. So let's see, function row. And what does this need to do? This is gonna iterate over. And I'm guessing this has got to take, these are column names, right? They're being passed to select. Yeah. Anyone do this with a reduce? Anyone? You guys reduce your way to the solution. New row, call name. So I'm going to reduce over this pass-in array. Let's see, and I need to provide a new object here. Can anyone tell me what I need to do inside of this reduce to make this work? Yeah.
Well, for one, you need to be looping over the column names that you're given.
Mm-hmm.
And what you need to do is you need to set the properties on new row for each key that you have in the column names to the value of the same property in your existing row.
Like that?
Yeah.
And I also have to provide an initial value, right?
Right.
Which is this object. Yeah. Okay. Cool. Return new FQL selected. Boom. Okay, makes sense? Everyone with me? It's kind of high up. Okay, your silence tells me that everything is fine. Yes. Thank you for mentioning that, sir. Reduce transforms arrays, right? It's not a for each. I have to return within it. What should I return? Okay, great. Oot. Okay, let's see. Oh, I've got one more where spec. Got a select spec. Okay. I think that's it. So if I all right. What's that? No failures. All passes. Cool. There's only one spec for select, so that wasn't a terrible one. No, there were two. No, there were one. Okay, great. So another way to do this would be to do it with a for each. You guys want to see that? You guys feel comfortable with the reduce? Yeah? Okay, great. So order is next. Yeah.
Request in a column, and it sorts the data set that we have in ascending order by the values in that column.
And how can I do that? Yes. Great. But I guess I gotta, and sort, does that return? It sorts in place, right? So let's just name this one comparator, because that's, and I can just say, so row B, right? And then what do I need to do in here? Come on, you guys have used sort before, right? It's this whole like A minus B kind of thing, right? Does anyone know how that works? Yeah.
If the value is less than 0, then it means that they have to switch. Or if the value is less than 0, then they don't have to switch. If it's greater than 0, then they have to switch.
Yes. Something like that. Yeah. No, it's one of those. Cool. So row A, the property, the value at row A minus col name of row B, right? Great. And then this sorts in place, right? So then, should I remove this assignment? Did anyone do an assignment here? How did you guys do this? Yeah.
You need to make a copy of it so that it doesn't like change the original array. You need a copy of it using slice, and then sort of the copy.
Okay. Okay. Okay, so that's clever. So you're like var, what, to sort. It returns the array?
The sort method sorts the elements of an array in place and returns the array.
Okay.
In places in italics.
Does that mean this will work? What's that?
Won't it fail the second test?
Yes, because, well, for one, I definitely need to do this. Right? But do you think this will work? We'll see. Okay. Let's get rid of these orders. Order. Boom. Check it out. Seems like it worked. So what does that mean then? If I didn't have to, because we're talking about the difference between like for eaching and mapping, right? And so I sorted this array and then I assigned it to a value. Or rather, I stored the value of that sorted array in sorted, and then I returned it. So that means that this does return something, right? I mean, otherwise I wouldn't be able to assign it, right? It'd be like trying to assign a for each transform. You guys know what happens when you try to return from within a for each? Yeah.
No, but I'll guess. Does it
No, I don't think so. Pretty sure it just returns undefined. So you just keep your transform. Yeah. What's that? But you can return, of course, within a for loop. So there's that. Okay, we can just continue. Okay, so now we're on level 2. It's kind of arbitrary. But now I need to do the left join. All right, this is like kind of where it gets kind of tricky, right? Okay, so anyone want to tell me what I need to do? Let's create a roadmap. What's a roadmap here? Presumably you folks did this. Yeah.
Well, we like sorted, went through each table, like the table or like the this table, this data, and also inside of that we went through the table we're trying to merge and just found all the rows that match, and just merge those two rows together, those two objects.
Each row in table A, go through each row in table B, right? And merge the rows.
And when you find that, when they do, if the particular function that they give you matches, they give their answer for those two columns out of two rows, then merge those two.
Okay, that sounds good. Sounds like something we can do, maybe. Okay, so I think, okay, let's see. So I think I'm going to need a new table. Here, we'll create array. And then, right, so I need a nested for loop, right? Which, again, as we discussed, is what time complexity? Yes. Yes. Well done. Okay. So, and then I have, and where am I getting? So this takes 2 arguments, right? Other data set and row matcher. I don't know why I called this other data set. That seems weird. Oh, the data set that's not this data. Okay, great. Okay. Other data set dot data dot for each. I guess I can call this other row. And then, so basically, I'm given a function to call this row matcher because it's a verb. And if row matcher, right, of row, other row, making sense? This will return a Boolean in the same way that any function that's provided in one of my query objects for the where must return a Boolean, right? Okay. So if it matches, if it passes this function that's passed in by these test specs, then I need to create a merged. I will merge them. Cool. And now what? I gotta push it. Great. Push merged. Cool. Do I need to do anything else? Turn this table. Cool. Got it? Okay, so let's break this down. So what is this doing? Because we're going to have to, let's see. So this is, we go through each row here. And then for each row, I'm stopping and going through every row in this other data set. Go through each in other. This is pretty self-explanatory. If match, merge. I'm just reiterating what we just wrote, but I think comments are good. Great. I think that's it. I think this should work. So let's try it. I'm going to left join, and we're going to right join, outer join. Let's see. I guess this is a spec as well. Boom. Okay, great. We're winning. Man, I'm tired. Okay. Any questions? Let's pause. Is everyone with me? Are you guys tired? Are you paying attention? You guys with me? Okay, great. I want this to make sense, in particular because this is, these pieces of functionality you're going to use from now on. Once we start working with ORMs, which I know I keep referencing, and you're like, what is this? But that's basically what this is. It's a higher level of abstraction for sending queries to a database and getting data back. And that's exactly what we're doing here, kind of. Right? Okay. Great. We've got our left join.
Can you walk through the if statement inside that?
Walk through, excuse me?
The if statement, like line 106.
Okay, 106, right. So what this is saying, so we have a row matcher function, right? That's pass. This function left join takes another data set as well as a function, row match. I've called this row matcher, right? And this function will determine for me if, will provide the criteria with which I will assess whether the two rows match, right? So it returns a Boolean. It's like if it's doing a bunch of if checks you can imagine within the row matcher. And then it's like, okay, if you pass all the if checks, then return true. Otherwise, return false. If it returns true, right, so this will evaluate to either true or false. If true, then merge it. If merged, put it in the table. Okay, great. Okay, what's next? Add index. Okay, so this is going to require a full-on table scan, right? Table scan. Yay. Okay, great. So what does add index do? Yes.
It creates a reference table that basically,
We'll call this index.
okay, so it creates an index that stores the indices of every element in the table based on the column name.
Mm-hmm. So we're creates an index for this column name, right?
Column name, yeah.
Cool. And what is that index going to look like? What kind of data structure is it going to be?
Hash table.
It's going to be a hash table. Does it have to be a hash table? Okay, great. What else? Where should I store this hash table? Okay, on the FQL object. Cool. That means I have to go back up here and modify this. I will name this index tables. And this should be a hash, an array, an object. Cool. So I've got this index tables now. That is a has-own property. I can access it wherever I want within this prototype object. And then what? So let's say that this index tables that I just instantiated is for like all the index tables I might want to create for this data set. Okay. So then I will need another index that's particular to this column. Okay. So there's my object. Okay. Now what? And to be clear, this is going to be something like, let me think. This is going to be, so what were the keys of this index table be? Yeah,
Column names.
column
Or not
names.
column names, the values of the column name for the given element.
Right, so say I'm trying to create a hash of like last names. So e.g. last names. Then what's my last name? It is Wilson. So for example, this will be Wilson, and this will map to an array, right? Of like numbers like this. That's kind of like what we're going toward. These will be primary keys of objects in my data set. Right? Cool. It's helpful to just, create these diagrams, know what I'm doing. Okay, so that's what I'm trying to get. This is my index table of last names. Okay, so now maybe I can start. This data for each function. Okay, this is going to be a row. Okay, what now? This guy, yeah.
So you want to add into the index for the row's value, so for your variable index, you want to insert in the property of the value of the row.
Yep.
Row.
Mm-hmm.
You would the index of the row.
Right, so I got to capture the value here, right? Column name of row. That's the value that I want, that I'm interested in, right? And then I have to see, are you already in there? Is Wilson already in my table? Is it there? Okay, right, so this is the value of the field that we were creating an index for. It's kind of, it's like repeat that over and over. Okay, this is the value. Okay, so if it's there, then what?
If it's there, then you would just push it onto that array.
Okay, so you want me to push here?
Well, if it exists.
If it exists. So should I do an existence check? Yeah, okay. And it's going to be an array, right? So I'll know if it exists if it's an array. You guys remember this static? Array is array. Okay, so if it's an array, then what?
Push it onto the array.
Okay.
Or push the index of the row onto the array.
Index of the row into the array. Cool. I want you to tell me exactly what to do. So how do I know the index? I already just gave you a hint by moving my cursor. Okay, great, thank you. Making it easy. Okay, right, so I'm gonna figure that out the easy way. Right, because that's the second argument to any array prototype method. It's the index of the element. Okay, is this right?
Well, you need to also create it if it doesn't exist.
Great, thank you. So else index of val. So if you are not there, then what? Be an array?
Create an array with the row index.
Cool. Does this look familiar? Is this what you guys did? Okay. So another way of doing this is like the way, I feel like this might be a little verbose for my taste. So this is basically the meaning of what we need to do, right? Another way of doing that is just to say, and this is like more common, would be to say like, if it's there, or instantiate it, one line, right? Array is array, right down here, index val. Ask a question, are you truthy? If so, then push row index, right? If not, you guys are familiar with these ternary operators? Yeah? Val. That was good.
No, because you're not initialized. You're never. It looks good.
Okay. Are you sure?
Sort of. I don't see why we need to have the check on 140 if we could just instantiate it on 141.
Yeah.
So we could just push the or set the index val to the array of row IDX.
So I don't need this line, right?
Yeah.
And I can just do what?
Row IDX.
Okay, great. I think you're right. I think this is the way to do it. Beautiful. That's like that's so much more concise. Everyone clear on what the ternary operator is doing? Yeah. Okay, great. Still not done though, right? I've got one more step. Remember, this is the index for last names, but I've created a hash to store my indexes in. That's right here on line 39. So I've got to add this index to the index tables because I'll have many indexes, indexes, yeah.
It's better to have an object like your index table of all your indexes. Index tables, so like one for name, one whatever, or just having like on the FQL, just having like another object that's like this for name, this. Versus instead of having them all inside of it's better to do it that way.
I would say that it's better to store all of your indexes in a data structure that consolidates them. Yeah, so that it's clear. Also for easy access of each index. Cool. Tables. This index tables call name. So this is what makes it my last name index. Boom. I'm putting it in my index tables object. And now I have it. I have complete access. Okay. Are we comfortable with this? Comfortable enough, I think. Okay. Let's save it. Let's try it. This is how I will create my index. Let's see. Add index. Oh, I've got this other method I need to write, right? So that's great. That's so much fun. So let's try get indices of now. Let's not even try and make this thing work. Indices of. Cool. Okay, what is this doing? This is the last one, right? Home stretch. Let's go, guys. Yeah.
So it's taking a column name and a search value.
Search value, search val. Yep.
And if the index exists, then you return the indices of that value.
Of val. Great. Right, because like what good is an index if we don't have a method to actually retrieve things from it with? So that seems pretty straightforward. Just that index tables. I have to do an existence check because I might be given something that actually doesn't have an index, right? So check for it. And if it's there, how easy is this? Direct access. That's how easy it is to find all the indices of the objects that I'm looking for by a certain value. Access, direct access. Cool. Now, you guys probably got to this point and were like, okay, great, I'm done. Fini, I'm going to run these test specs. And then it didn't work, right? Still broken. Because you had to go back and rewrite where, right?
Also, now it's supposed to return undefined if it doesn't find it.
Well,
Because JavaScript,
it take arguments though. Yeah, it doesn't take arguments.
that is a good point. It needs to take these guys, call, name, and val. Right, and JavaScript functions return undefined when they return no value. Although it is an open philosophical question of whether that would be the same thing as returning undefined, right? Think about it. Some functions return the value undefined. Others return nothing and return undefined implicitly. But is that the same?
Well, in JavaScript, that would be the same because no would represent a value that doesn't exist, and undefined would just represent everything else where there is no value.
Right, undefined means, well, undefined has like two meanings in JavaScript, right? It's like doesn't have a value or something in between undefined and null. It's like a nil state. But let's not do that right now. There are people writing like papers on that. We'll talk about that another time. Okay, so then at this point, so if I save this and I run my specs, actually I should comment these out. Boom, boom. You can also just find them all. Okay. Yeah, I remember doing this and being like, wait, fail? Like, I'm pretty sure everything's right. Why is it doing this to me? Right. So at some point, maybe you went back and sort of changed where. Did anyone do that? Great. I'm seeing some yeses. Okay, so I won't ruin the fun by telling you like why exactly we have to do that, but we do. Basically, we need to get where, we need to write a where that will use our index, right? Because like what good is an index if when I try and where filter down my table, it's not using that index for the column names that it can, right? Okay. So
Can you say the original one?
yes, I will do this. I will call this old where. No, where without index. Okay. And this will be new where. New where with index. Okay, anyone want to tell me what to do? We're so close, home stretch. Yeah.
So for every key that you received in the filter object, you need to check to see if you have an index for that particular key.
Cool. So, right, it's the same thing as old where except for it uses the index when possible, right? Cool. I'm just gonna try and pump that out. So I'm gonna store this data in another table. Boom. I'm gonna need this for this argument gets a little lost. I'm going to, as I did before, grab all the keys from my query object. I'm going to for each on those keys. I have to check for each field that's passed in. I'm calling it field here, but remember it's just a key. Keys. Self.get indices of. Field. Query object of field. Okay. Makes sense. Is it clear why I need to reference this via self here? Yeah. Great. And if there are indices here, then I will do something in particular. Right? If not, I will do something else. Okay. So what do I want to do if there are indices? Basically, I want to retrieve by index because this is super fast. So I'm winnowing down my search area, field by field here. Boom. So I'm going to take my new table, which is like the big result set. You can imagine, remember when we would do the from wheres, and I would say where, you can do and. We're grabbing all the data. I'm going to like just winnow everything out that is unnecessary. So that's what's happening here. Function, what is this? Row IDX, return self, that data. of row IDX, right? Because these are the indices that are matching to where that data is located in the big table, in the original table, right? That you would list on the from line in a query. Connections, okay. Great, and this else is, so this is, right? This is if there are indices here. If I have an index on this field, on field, right? If not, cool. So if not, then what? Then I have to scan the entire table, long search, do the old-fashioned way. Okay. New table. So now I'm going to use a filter, right? Row, boom, boom, boom. And it's basically the same thing that I did before, right? Because now I just have to check if it's a function or a property. Yeah. Great. Type of what? Query object of row. No, sorry, I'm calling it field. Getting confusing. Okay. Function. Then what? Then if not, query obj, right, of field, passing the value at that row of field, boom, return false, if not, right? So if it doesn't match, if my row matcher is not returning a Boolean, it's not returning true, then return false. And then what? And then I have to check if it's another type. So else if row of field is not equal, but query object field. So if it doesn't match the property that's passed in, then return false here. Otherwise, what? Otherwise, return true. Boom. Because filter must, so you guys know that when the criteria of the filters, right, is just returning a Boolean. So we return, and if it returns true, then it returns to us our object for which we return true. Okay, great. And then the last thing is, so this is my big, this is all within this mega for each. So yes, I have to return the table. But before I do that, so get indices up. Let's like scan down. What's that doing? What's the time complexity if I have an index? Basically what I want to be asking. Is it constant time? What's that? Yeah, it's n. It's n if I have an index. And what if I don't have an index? N squared. Boom. Same time. Which you guys experience with the queries. So it's like not theoretical to you. It's very practical. You've lived this truth. Okay, great. As always, I have to return functional new table. Boom. All right. New where? Let's see. Let's see. Boom, boom. Great. Yay, we did it. Any questions about this? Did you guys like this workshop? You feel like you learned something, made things clearer? It was cool to write in the functional programming paradigm. You guys are like, yeah, I'm going to become a functional programmer now. Screw object-oriented. That's so lame. No? Yeah.
We didn't really, like, I don't think that most people didn't quite make it to the last two problems, so,
Yeah.
yeah. They seem actually pretty important to have gone through.
I would definitely recommend that you folks finish it on your own and then consult the solutions. And if you have questions once you do that, please ask me. I would love to make sure that you guys understand this stuff. I know, yeah, not much time. There's never any time. That's life. Yeah.
So how does your where function work now if you're past it multiple filter criteria and you have an index on one?
How does it work?
It would overwrite the values that you're storing, wouldn't it?
Would it overwrite the values that I'm storing? Let's see. So if I have this index here, I'm winnowing down new table by these indices, right? And I never hit this else condition if it's an index.
Right, and now if you have the second or then you also overwrite the results that you had in the first one.
Exactly. So it's like really just, and that's why I'm doing it with the new table I'm reassigning, because I'm just sort of like cutting out the fat until I get to the good stuff.
Right, but you would produce an incorrect result then.
Would I?
If you were looking for, like, instead of just last name Russell, if you were looking for Kurt Russell, and so you go through, you don't have an index on Kurt, you find the Kurt Russell that's in the database, and then you go through again, you look for Russell, then you have an index on Russell. So you would take everybody that has the last name of Russell and put that in the table, and now you no longer have the table of Kurt Russell, you have everybody that's Russell.
Oh, so you're saying like there's a problem with compound values. Yeah. Yeah, that would be 3.0. Yeah. Okay, great. I upload these to the library, and yeah, and then we're gonna do. You guys have promises tomorrow. That should be fun. So great. Have a good evening. Peace be with you.